this is just to correlate the today's lecture with the previous lectures. अच्छा ये उज़ैर ये बताएं कि आपसे शेयर हो गई थी ये सेक्शन वाले ने स्लाइडें?
यस सर।
ये जो क्वेश्चन भी थे, क्वेश्चन और उसमें वो सॉल्व्ड एग्जांपल्स।
यस सर, वो मैंने शेयर कर दी हुई है क्लास में।
ओके ठीक हो गया, चले। तो as far as the basic terminology is concerned, stiffness, you know, this is the force for against unit displacement. If displacement is unit, then this is known as stiffness, and this is the force. And inverse of this one is flexibility. Secondly, this is the compatibility, that at any support or connection, there will be the elastic that will be fulfilling all the basic principles of mechanics. Like over there, it cannot move up and down. There will be rotation that can be, but over there will not be any rotation, no linear translation. And in this case, all this has been already considered. This is showing you the continuity of the support or continuity of the common point.
एक्सक्यूज मी सर, सर वो कुछ स्टूडेंट्स कह रहे हैं कि वो एंटर नहीं हो पा रहे।
क्यों नहीं हो पा रहे? मैंने जिनको किया हुआ है वो बिल्कुल
सर शायद वो कुछ मिनट लेट हो गए हैं या फिर नेट उनका डिस्कनेक्ट हो गया, इस तरह कुछ इशू हो गया।
तो I also explained previously theta b matlab this is showing you the continuity of all the members which are meeting at joint B. Now when you are interested in finding out this rotation or this deflection, you can see this deflection. For that you can have the advantage of unit force method, unit load method, Castigliano's theorem. Now in this case you can see that the delta is the deflection or the displacement. It can be found by mx, capital M, which is showing you that resembles the effect of the load in terms of moments which have been produced by the applied loading. Whereas m small, this is due to the unit load, bending moment due to unit load that has been applied at the point of deflection. Okay, this is well known to you. Now this is one approach. The other approach is that you can directly put the values of theta and delta, whichever is suitable, and for that you need to remember all these relevant formulas. This is only typical example have been given over there, that if there is a cantilever beam and there is a point load over there.
वो लिंक नहीं आ रहा पुरानी।
क्यों?
पता नहीं सर।
नहीं, आपको एडमिट किया हुआ है?
जी किया हुआ है, लेकिन वो आ नहीं रहा।
नहीं, ये कौन है? इधर तो कुछ नहीं है। ये हमामा आप ही की क्लास की है उज़ैर?
यस सर।
इसको क्या मसला हुआ है? फिर
ये कोई न्यू कन्वर्सेशन नहीं आ रही, मैंने टेक्स्ट किया।
इनविटेशन नहीं आ रही?
नहीं, ज्वाइन लिंक नहीं आ रही।
मैंने तो सेंड किया हुआ है, रोल नंबर बताओ। So I was talking about the mode or the method for the solution of the numerical. ठीक है? Either you can directly put the value if there is a cantilever beam and the load is at the tip of this beam, and you are interested in finding out this delta and theta, then directly these values can these formulas can be used. Also, you know the reciprocal displacement theorem, Maxwell. If you are applying the force at this point, okay, then there will be deflection at some other point, and now in the second phase you apply the same load, and then there will be deflection at the previous point. These 2 points will be showing you the similar displacement. It is there is no binding where should it be placed, and except the support. Certainly at the support there is no load that is acting, and even if you have placed the load, it will be directly cancelled out by the action. So you need not to talk about that one, because this law of reciprocal deflection or the displacement, this is valid for the elastic member. Support is not the elastic member, whereas the beam is the elastic member. So if you will be applying the load on the at any place, okay, this may be B, and this A can be chosen anywhere. That may be in between, this one in the middle. And if you are interested in ascertaining this or proof for this Maxwell law of reciprocal deflection, then the instrument or the experimental setup that is available in the lab, test floor lab, upstairs, and you can check it, you can verify. So there is no binding where should these be placed, but there is binding that the same load should be placed at the 2 places, and the other at the other location, there will be deflection, both are same. Delta AB and BA, this will be same, and the same is the case with this one. So these have been already described. Once again, this is just to make you very clear about the procedure. Otherwise, all these things have been explained already, just to facilitate you in for better understanding and to have a better view about the force method. Also, now this method is applicable for the indeterminate structures. Now, if there is one, in this case, you can see this is a proper cantilever beam. In this case, there are 3 reactions and 4th reaction. So -3 of the equilibrium equations. So it is this is 1 degree excess. Well, that is known as a degree of indeterminacy. So single degree of indeterminacy is there for this beam. Now it will be equal to, if I just break this beam into two parts, okay? So just I convert it into the primary structure. What are the properties of the primary structure? Primary structure is a structure that is stable and that is determinate in nature. That is stable and determinate in nature. Okay? So this one plus the reaction that was removed, that was isolated, that was broken, separated, isolated. This can be shown separately. And if you combine these two, the first one, these two figures, these two beams, then it will be equal to this one. So this is in accordance with the, this will be in accordance with the law of superposition, principle of superposition. These two will be, effect of these two will be equal to the effect of this one.
Excuse me, sir. सर वो स्टूडेंट कुछ कह रहे हैं कि अगर पॉइंटर आप ऑन कर रहे हैं क्योंकि ये वाइट कलर है तो ये मतलब सही नजर नहीं आता।
नहीं तो ये इसमें ये मैंने कर्सर तो ऑन किया हुआ है ना, कर्सर।
सर वो कहते हैं कि कर्सर का कलर वाइट है तो वो मतलब सही नजर नहीं आता जब आप मतलब पढ़ा रहे होते हैं, तो वो आप पॉइंटर ऑन कर लेना किसी और कलर के साथ तो वो शायद इजी रहेगा थोड़ा।
अच्छा, पहले तो कभी ऐसा नहीं हुआ, मेरा नहीं ख्याल कि भाई ये आपको जो है ना अब अब नजर आ रहा है? पूछो शिया।
सर अभी
भी नहीं आ
सर
रहा।
साइज शायद इसका छोटा है, नजर
साइज
तो आ
बड़ा
रहा
कर
है।
दे,
यस
साइज
सर।
बड़ा कर देते हैं जनाब। आप ठीक है? अब ठीक है?
यस सर, आप बेहतर है, लेकिन सर अगर आप कोई मतलब कलर थोड़ा ब्राइट कर लें, ये ब्लैक है जरा, मे बी इसमें भी इशू हो लड़कों को। यस सर, आप ठीक है।
अच्छा ठहर जाओ। अब ठीक है? मेरा ख्याल है कि इसमें भी होगा मसला।
सर वो जिस तरह पहले आपने जरा लार्ज साइज किया था वो सही था।
अच्छा लार्ज साइज कर, चलो ये लो। अब ठीक है? ये अभी भी
यस
कुछ
सर।
मसला?
सर अब ठीक है।
ये ठीक है, ये अब सही है। अब ब्लैक है, ठीक है? ये तो ठीक है?
यस सर। यस सर, अब सही है सर। वो एक दो स्टूडेंट अब दोबारा कह रहा है कि वो फिर से ऐड नहीं हो रहा, पता नहीं
तो
उनका क्या
यार
मसला आ रहा है।
ये छोड़े बस, मतलब है कि ये उनका अपना मसला। मैं अब मैंने तो सबको अलाउ किया हुआ, किसको मैंने अलाउ नहीं किया हुआ?
ओके सर।
फिदा हाफिज, बस वो ऐड हो रहे हैं बस, ठीक है, आहिस्ता आहिस्ता हो जाएंगे। अच्छा, so in this case you can see this is the prop cantilever beam. This has been broken into two separate beams under the situation of principle of superposition. Now the combined effect of these two will be equal to the effect of this beam, actual beam. Now in this case, if you take the redundant vertical force as a redundant, if you take vertical force as a redundant, if you take your vertical force as a redundant, then what will be the situation? This will be the primary structure. So this is determinate. And what will you do? You will add at that point where you are interested in finding out the reaction, you are redundant. Over there, you will be finding out the deflection. Now, from this deflection, this will be this is delta B, and you will be applying the redundant force from the downward side or upward side, downward, any direction that can be taken, assumed, arbitrarily chosen, and at the end you will see that if the result comes out to be negative, then it means your chosen direction that was wrong, and you need to correct it, or you need to reverse the direction of the applied force. Okay, everything that has been explained already. P is equal to KD, D is equal to P over K. P over K, 1 over K जो है वो flexibility है. Flexibility means flexibility या delta, ठीक है, और ये P जो है ये सेकंड केस में BY है, तो ये डेल्टा B है और ये डेल्टा डैश BB है. When you will be adding up these two, delta B plus this should be equal to 0. Reason is that it is stable structure, and for the stable structure there is no displacement or the deflection that you have observed. You will be observing. So the summation of these two displacements should be equal to 0. So this is as far as the procedure is concerned. Okay, I have already done explained it earlier. Similarly, so this way you can see this is minus, because that was downward displacement. In this case, this is downward, so it is negative. It is upward, so it is positive. So when you will be adding up, the result should be 0. Okay. Now, if I replace this delta dash BB, it will be equal to BY, the force into flexibility. And now you can find that delta dash BB as flexibility and BY, and BY can be delta BB over FBB, or delta BB जो है that can be found from the concept of a unit load method, and this is very easy. So this is this is regarding the situation when you have considered the linear force as redundant. Now if you are considering the moment as redundant, then it should be seen that this situation will be converted into hinge support, because if you will be considering the redundant means which is inactive. redundant का मतलब होता है कि जो वहाँ पे एक्ट नहीं कर रहा, ठीक है। तो ऐसे केस में आप क्या करेंगे, जब मूवमेंट आपने अलहदा कर दिया तो फिर इसकी कैफियत जो है वो हो जाएगी hinge support की. This will resemble the hinge support. So it will be, this beam will be equal to now this beam will be equal to this one plus moment. So this beam has been broken into two parts. This is the primary structure which is stable. You can see this is hinge support and this is roller, so it is stable. Okay, and also it is determinate, and plus at this end you will be applying the moment. Now its direction may be clockwise or anti-clockwise, irrespective of any binding. You can apply the force. And wherever you will be applying the force over there, you will be applying the unit movement, you will be finding out the rotation. So corresponding to moment, there will be rotation. Corresponding to the linear force, there will be the displacement, linear displacement. And so P is equal to KD. In the previous slide, this is given over there. So F into P. P means load, load means moment. F is the flexibility. What is flexibility? Is the displacement or the deflection. So displacement is the rotational displacement. It will be in the form of rotation alpha. Okay. So this way we will be finding out the and now in this case you can see that this rotation and this rotation, the sum of these two rotations should be 0. What is the reason? Because in actual structure the beam is stable, determinate and stable. Beam is determinate and stable. There is no deflection or the rotation at this point. Okay, at a point. This is by the mechanics. So the sum of this theta A and theta AA should be equal to 0. And at the end you will see that moment comes out to be negative. Now this is theta A plus this theta dash AA, and in place of this one, this can be replaced by this one. This is the force, this is the flexibility. And if you solve this equation, then MA will come out to be negative. It means this is showing you that the direction of this movement is wrongly chosen. It should have been leftward, applied leftward. It should be noted. So this was regarding the just the review of the previous basics of the force method. And you might have also, you were given the assignment numericals, and I hope that you might have attempted all these numericals at your places. So today we will be displaying the numericals which have been solved. Once again, I share the window. Anji CR, can you see this one?
Yes, sir. Yes, sir.
So everybody is required, everybody, to keep your notebook with you, everybody. Whatsoever I speak, everything will not be written in the slide. Whatsoever I speak, that should be rewritten in your on your notebooks. And also, all these sort of numericals and the assignments should be solved separately on your assignment register. This is the requirement by OBE system. So this is necessary, whereas the class notes should be separately prepared. This is necessary. Now, you need to redraw this one. Everybody is required to redraw this figure, this figure, this figure, this figure, and the remaining ones. Everybody, please redraw it. Must be vigilant. It is necessary. Yaad rakhna. So whatsoever I speak, that should be rewritten according to your own will or in your own words. Now in this case, you can see the previously solved examples which were shared with you. Those were regarding the numerical which was having degree of indeterminacy 1. Now, if there are 2 or more degree of indeterminacy, how those should be solved on the same lines? There is no difference in that one. There is no difference in the procedure. Only you need to clarify the concept, how you be solving it. Now this is a beam, prop cantilever. This is also continuous beam. This is continuous beam, which is resting over more than 2 supports, and you can see this is 3 reactions are there, 3, 4, and 5. So -3 of equilibrium equation. So it comes out to be 2. So degree of indeterminacy is 2. Now extra equations which are required, that is, those are 2 in numbers. 2 equations are needed. In the previous shared solved examples, you might have seen that there was only one equation that was developed. But over here, I need, and in that case, you easily calculated and solve the numerical. Now over here, degree of indeterminacy is 2, so you need 2 equations. How can those be developed? See, it will be equal to, it is written, it is equal. So this is 3 meter, 3 meter, 3 meter, 3 meter, 80 and 120, A, B, C, and this is D, and this is F. D, or this is E. Now it is equal to, I will have to remove 2 reactions. Those will have to be considered as redundant. Okay? So for my facility, you can adopt any approach. So I have taken these 2 forces, reactions, VC and VB, as unknown or redundant. Now that if I break this structure into different parts, then just by removing this support or the reactions which are acting from the underside of the beam, I will be rendering this beam into a primary beam. This is a primary structure. You can see the VB, vertical force at point B, vertical force at point C, in the form of reaction. Those have been assumed to be redundant. Those have been removed, and the rendered structure that is determinate and stable. You can see this is fixed support and this is cantilever beam. So this is determinate and stable, and these 2 are the bindings and the properties of the primary beam. Plus, separately, considering the law of superposition, principle of superposition on one beam on this structure, VB has been applied. On the next one, VC has been applied. VC has been applied. So you must listen carefully, must be vigilant. Now, at the locations where you have considered the forces as redundant, over there you need to find out the deflection or rotation. Now, if you are considering the linear force as redundant, then corresponding to that one, there the deflection or the displacement will be linear. It means deflection. So I will be considering when VB is acting, and in this case VC is acting, and at the same location B and C, I will be considering the deflection. Now, under the effect of these actual loading, okay, on the beam, there will be delta B, okay, plus under the effect of this redundant, I have applied it to be downward. Actually, this may be upward or it may be downward. I have told you, I have clarified it previously, that this is arbitrarily chosen direction. Whether you apply it upward or downward, it will make no difference. At the end, you will see that your result is negative. It means you have chosen direction that was wrong. It should have been applied in the other direction. So this is delta B, and under the effect of this VB, I have labeled it as delta dash BB. Okay. Now, see the definition and hear the definition. Listen carefully and note it on your notebook. Note it, please. Delta B simple with one single subscript. This shows the deflection due to applied loading. Deflection, displacement due to applied loading. Whereas this, what it denotes that this is delta dash BB. It means this is the deflection. Listen carefully. I am defining it. This is deflection at point B due to force at B. Deflection at B due to force at B. Is it clear, CR?
Yes, sir.
और ये GR कौन है? GR है कोई?
Yes, sir. Yes, sir.
क्या नाम? मनाहिल. अच्छा, ठीक है. ये आप भी अनम्यूट रह सकती हैं, अगर मतलब कोई ऐसा मसला नहीं है तो आप भी अनम्यूट रहे, ताकि सुनने में आसानी हो, रिस्पॉन्स देखने में. सो इट इज deflection, see, it is deflection at point B due to force at B. Once again, it is deflection delta dash. Dash means redundant, due to redundant. This is the nomenclature. So this is the notation. Deflection, you can write it on your notebook. Deflection at B due to force at B. You can see. Okay. Now, at the same B point, when you will be applying VC, then at the same point there will be deflection, whether it is small or large, irrespective of that, there will be deflection. And I have written it to be delta dash BC. What does it mean? It means deflection due to redundant force at point B under the effect of load applied at C. It is deflection at B due to force at C. It is deflection at B due to force at C. In short notation, definition, this is deflection at B due to force at C. Now, from the principle of mechanics, you can see this beam is in stable condition. It means there is no deflection. it means whatsoever the procedure has been adopted by bifurcating, by breaking this beam into 3 parts, at this location, delta B plus delta dash BB plus delta dash BC, sum should be equal to 0. Sum should be equal to 0. This plus this plus this. Whether it is being shown downward, it will make no difference at all. You will see that automatically it will come out to be 0. It should have been 0. And also the direction of VB will be finalized after your calculation. It will be negative. It means you have wrongly applied the loading. You have wrongly chosen the load direction. It should have been applied upward. Take it. Similar is the case at C. Come to this point. Come to this point where you have considered the redundant. Now over there, this is delta C. You can see from this to this. This is delta C. And what it defines? It defines the deflection at point C due to actual loading. This is due to actual loading at point B. This is due to actual loading at point C. And what about delta CB? It is CR, ये इसको दोहराओ बेटा. Delta dash CB क्या मतलब है इसका?
Sir, deflection at C due to the load at B.
Shabash. Deflection at
redundant load at B. Deflection at C due to redundant load at B.
शाबाश शाबाश, ठीक हो गया. इसको भी डिफाइन कर दे. डेल्टा डैश CC का क्या मतलब होगा?
Deflection at C due to redundant load at C.
Shabash. So everybody is listening that this is the definition of this. This is the explanation of this notation, that this is the deflection at C due to force at C. Deflection at C due to force at B. Now, same approach will be adopted for this support C, that delta C plus delta dash CB plus delta dash CC summation should be 0. Why? This is stable, not moving up or down. So this is stable in the vertical direction. So in all the cases, so this is our approach.
सर
हाँ जी.
सर दो लड़कियां कह रही हैं कि मीटिंग में नहीं उनको एंटर किया जा रहा, तो प्लीज कर दें.
ये पहले भी बाय इसको एडमिट किया था, फिर इसको क्या हुआ? हम मामा और जुनैरा.
सर वो कह रही है उसका नेट डिस्कनेक्ट हो गया था.
Okay, so now from this observation you can formulate an equation. Which one? That is the first equation. Delta B plus delta dash BB plus delta BC should be equal to 0. This is one equation. So bhai, ठीक है? CR.
Yes, sir.
This is first equation. Second equation is this one. Delta C, delta dash CB, delta dash CC should be equal to 0. This is the second equation. Now I need two equations for the solution of this numerical, and at this moment I have formulated this one. And on the left side you can see delta B, delta dash BB, BC is equal to 0. Delta C, delta dash CB, delta dash CC is equal to 0. Now I have obtained these two equations. Now I can move further. Now if I replace the values, notations with their corresponding expressions, then you will see that this delta BB, this is deflection. And what is deflection? Deflection is basically the flexibility. What is flexibility? For your remember, just to make you aware and for your revival of the knowledge, P is equal to KD, D is equal to 1 over K into P. ठीक है, ये इधर आ जाएगा. 1 over K into P is equal to D. और 1 over K क्या है? Flexibility. Flexibility क्या है? Deflection है basically against unit force. Against unit force. क्यों भाई? Flexibility क्या है? CR
सर यूनिट फोर्स की वजह से जो डिफ्लेक्शन
डिस्प्लेसमेंट, हाँ जी डिफ्लेक्शन है। हाँ जी एनी अदर GR
Yes, sir.
can you define this flexibility in short? Flexibility is deformation. नहीं आ रही आवाज? Hello. So this is displacement or deflection with unit load. Yeah, you can see if I place it equal to 1, then this flexibility will be equal to displacement. CR सुन रहे हैं ना आप?
यस सर।
ओके बेटा म्यूट रहे, मुझे पता चलता है कि चलता रहे ताकि कि ये जो है ना आवाज जा रही है। सो दिस इज डिस्प्लेसमेंट। अच्छा D has been replaced by delta F by delta small delta that shows unit displacement for unit. P is equal to this one. So corresponding to this one, delta is equal to P into delta. So this delta is equal to VB because over there you have applied the force of VB. This is due to VB. Delta VB is equal to is due to VB. So VB means force. This is force. Delta ये वाला BB आ जाएगा उसी तरीके से plus this is deflection at B due to VC. It means it should be VC बिल्कुल इसी तरीके से जैसे ये है, very similar to this one. It will be P is VC and this is delta, it will be delta BC. ठीक है?
Yes sir.
Now consider the second equation, delta C delta dash CB. What is this one? It is deflection at C due to load at B. Now this has been written wrongly. Please is rectify, इसको correct कर लें आप. VB, this is VB. वहाँ पर आप जो कुछ लिखे ये आपने दोनों इक्वेशंस लिखनी है अपनी नोटबुक में. ये फॉर्मर भी है इसमें CR?
सर आई थिंक एक फॉरनर है.
Is he present in the session? The foreigner? Foreigner?
Yes, sir. Yes, sir.
You are from?
I'm from Sri Lanka, sir.
Sri Lanka. Okay. So, are you understanding it?
Sir. Yes, sir.
So, all these equations should be written. This one first equation, and this should be with subscript B. VB. Please rectify this one. It is VB, not VC. VB, and it is delta dash CB plus delta dash CC means deflection at C due to load at C. Load at C is VC, and this is the unit deflection corresponding to unit force. So this is the, now we have obtained this one, this equation, this equation. Now these are the two equations.
सर एक स्टूडेंट कह रहा है कि लाइट ऑफ हो गई थी, डिस्कनेक्ट हो गया, तो दोबारा से एडमिट करना पड़ेगा.
Now in this case, if I am able to find this delta B, this small delta, this small delta, 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 then I can find VB. Two equations are there, two unknowns are there, VC and VB. This is VB. So VB or VC. So there are two unknowns, and these can easily be found by solving simultaneously. Now, how can these be found? This one and this one by applying the unit load. Now, when I apply, I will have to apply the unit load at point B and at point C as well, where I have considered the redundant forces. If I have considered the moment rotation. Then I will have to consider the rotation. Corresponding to moment is the rotation. Now, corresponding to this linear reaction, redundant, there will be unit load that will be applied at point B and at point C. Under the effect of this unit load, this will be delta BB, small delta. What is this? This is this is the displacement at point B due to unit load at B. And certainly under the effect of this load, there will be deflection at point C as well. And this will be labeled as delta CB. This will be deflection at C due to load at B, unit load at B. Deflection at C, unit load at B. Similarly, you apply the unit load at C, you will see that there will be deflection, small or large, whatsoever is the case, whatsoever is the value. Delta BC means it is deflection at B due to load at C, unit load. Small delta shows unit load. This is delta CC, deflection at C due to unit load at C. So all these have been, now this is the procedure. Okay? Now either I will be following the same one. I should have with me the formula that I displayed before displaying this numerical in the slides. Either I have told you that there are two approaches. Either you can use the unit load method, or you can use I have told you, either you will be using this one, unit load method, or you need to have with you the complete what I'll say table and corresponding to the loading. You should have this one against this sort of situation, and this is theta and delta against this sort of situation. So it is not possible to remember it or to have the table with you. So it is very easy to use the approach of unit load method. Is it right, CR?
Yes, sir. Yes, sir.
Okay. So साथ ही मैं इसको मतलब आपसे शेयर भी कर रहा हूँ सारा कुछ previously. So now the solution procedure that is given on the next pages. This one. This is the solution of this numerical. You also, everybody is required to prepare this table. Everybody. And as I speak, just fill it. As I speak, after understanding, you may fill it. So this will be a dual way for addressing the numerical or the solution of this numerical. हाँ जी, बना लिया सी आप?
Yes, sir.
Okay ji, listen carefully. You should keep everybody is required to keep with you the original structure that you have drawn. I have shared with you, and just compare it and then see how we are solving it. This is the portion I have divided the beam. You might be knowing it. This one, you can see that this is one approach. You can start it from A to A, D, DB. Just you will divide it into different parts, segments where the loading condition is changing, as you know, and you are well aware of this one. So first of all, it is CE, EB, BD, and A. ठीक है, CE, EB, BD, AD. Origin is taken from the star and from the right side. C, E, for keeping in view my ease or simplicity of the numerical procedure. So C I have chosen, and you know that you will be choosing the origin where you encounter the minimum number of forces. This is very simple. The origin is C, for EBE, for BD is B, and for DA is D. Limit is 0 to 3, and EI has been taken for facility as 1, or it can be ignored. Now, what is the moment? Moment, you need to define it. Listen it carefully, and you should write it in your notebook. On your notebook, M capital. What is this one? This is the moment due to applied actual loading on the primary structure. This is the moment due to applied loading. This is the moment due to applied loading. And you know that the basic formula is this one. Delta B is equal to capital M and small m. I have told you, and you are knowing it, that this is due to applied loading and this is due to unit loading. This is due to unit load, this is due to actual loading. So you need to have the moment capital M for all the segments. What will be the effect of applied loading in C portion, EB, BD, and AD portion? And what will be if you apply unit load? And then what will be the moment effect in this C, EB, BD, AD? So first I consider this one, capital M. Now in this case, you can see if you keep the figure of the beam in front of you, you will see that in the primary beam, in portion CE, there is no load, no force is there. If I consider origin as C, there is no, so it will be, moment will be 0. Moment will be 0. In EB portion, so first I consider this moment capital, then I will be moving further. In EB, you can see that in EB portion comes 80 kilonewton, which is acting downward. Everybody is listening carefully. Everybody. ABCR, is it clear?
Yes, yes, sir.
हाँ जी. अच्छा, ये 56 मौजूद है. 56. Please unmute. 56. This is random checking of the person. जी?
Yes, sir.
Okay. This is random checking of your presence. So you must be attentive. Ayan, are you present?
Yes, sir.
Welcome. Good. Okay. Uh, Friha Nisar.
Yes, sir.
Okay, okay. HD 4053. Who is HB? HB. If you will not be responding, I will remove you. Hanji, HB 405304. HB. सी यार ये कौन है HB?
Sir, I think Hassan Butt.
HB, are you present? HB, so I am removing it. This roll number. इसको मैं रिमूव कर रहा हूँ. ये जो है ना मतलब ज्वाइन करके तो फिर भाग जाते हैं बस लगा के. ओके जी. मेहदी खालिद. मेहदी खालिद. मेहदी खालिद. Mehdi Khalid. It is also being removed. Okay. Muin Awais.
Yes, sir.
Thank you. Rosie 74200.
Yes, sir.
Yeah, नाम लिखा हुआ है. Laiba. Laiba. कनेक्टेड तो है ये अभी ब्लिंक हो रहा था. लाइबा साउंड का मसला उसका. ओके. So once again coming back to the solution of the numerical. Now in case of EB portion, you can see 80 kilonewton force is acting downward. 80 kilonewton force is acting downward, and the limit starts from 0 to 3. So under the effect of this applied loading of 80, it will be 80 into x. X is a variable. At any location, you can find out the moment in along the length of this part EB. Minus 80x. Minus 80x. Is it okay? From the class, anybody can respond. From the class except CR or Chia.
Yes, sir.
समझ आ रही है सबको? सबको समझ आ रही है बेटा?
Yes, sir.
Shabash. Shabash. Welcome. So it will be minus 80x. Now I move to BD portion. Just keep the figure of the beam in front of you and just go through that one. In case of considering the BD portion, you can see that in BD only 80 effect of 80 kilonewton force is there. Now in this case, the limit is 0 to 3, means from B to D. Whereas the distance between E and B, EB, this is absolute. Okay? Or variation is between B to D. It means I can write minus 80 x plus 3. Okay? 3 will be absolute value, which is out of this range BD. Okay? So it will be 3 plus x. X is variable that is varying between B and D. Okay? Then is AD. In AD, origin is D, limit is 0 to 3, EI is 1. Now, in case of AD, you can see that there are two forces. You can see you can see in case of dA comes two forces in for this portion. Effect of two forces are there. First one is 80, the second one is 120. For 80, because it is producing hog, so it will be negative. And previously we have also written the negative sign with the moment minus 80. So it will be minus 80 into, this is 6. This will be absolute because under consideration portion is this one. And this is variable. And for variable portion, we will be considering the x value, x, the distance in terms of x. So it will be 80 minus 80 into 6 plus x, 6 plus x, and then minus 120 into x, minus 120 into x. This one, you can see that 86 plus x and minus 120 into x. So this is the effect of the actual loading on different segments of the beam. Now I move to the second requirement, which is the unit effect of unit load. So for
Sir,
that,
एक्सक्यूज मी सर, एक स्टूडेंट है उमर फारूक, वो कह रहा था कि नेट डिस्कनेक्ट हो गया था और दोबारा से एडमिट नहीं हो रहा।
ये अजीब है, पता नहीं समझ नहीं आती। इस सब का क्या मसला है? ये सुनहरा भी बार बार उमर मलिक मेहदी खालिद, ये मेहदी खालिद को तो मैंने एडमिट नहीं करना, दूसरा जो है उमर मलिक, तो किसको मैंने रिमूव किया था? वो और था क्या, इसको मेहदी खालिद को नहीं करना, सुनहरा और उमर। Okay. Now, as far as MB is concerned, and certainly there will be MC. Reason is that I need delta B, I need delta C. I need delta B, I need delta C. So I will be finding out MB and I will be finding out MC. ठीक है, इसी तरीके से this will be small mb and this will be small mc corresponding to delta C. So I need to develop the column of MB. What does it shows? It shows that it translates, this is the moment. You can write, you can write, it is the moment, it is the moment due to unit load at B. This is the moment effect of moment, this is the moment effect due to unit load at B. Moment effect due to unit load at B. And MC क्या है? Moment effect due to unit load at C. ठीक है? Now, if you apply the unit load at B, then just keep the basic figure with you. It for CE it is 0. This one you can see. This one you have applied unit force at point B. No effect over there because I am moving from C to E and origin is C. Okay? So there will not be any movement. It is 0. For EB, once again it is 0. Once again it is 0. But when I will be considering BD, then its effect will come because B is the origin. I am moving leftward. So effect of this one will be 1 into x, and it is downward producing hog, so it will be negative. It will be negative. So you can see for MB, CE is 0, EB is 0. After you have crossed the B point, unit load has been applied, 1 into x. It will be 1 into x. And for the next portion, segment AD, D is the origin, then you will see, you can observe that it will be x plus 3 minus ka. You can see for this portion, effect of this unit load will be 1 into x variable for this one plus 3. This is absolute value, x plus 3 minus ka, because this is producing hog. So this is the solution for MB. Similar is the case with MC. This is the unit, this is the moment due to load at C. And if you keep the diagram with you, in front of you, you will see for the first portion, for the first segment, it is minus x into 1, minus x. For the first segment, it is simply minus 1, 1 into x minus 1x. For second segment, EB, it will be 1 into 3 plus x. For the third segment, it will be 1 into x plus 6, 6 plus x minus. Or for the last segment, it will be 1 into 9 plus x, 9 plus x. It will be 9 plus x. So now this all basic parameters have been calculated. Now you need to find out delta. Now what I need from the previous equations, if you see, then you will see that I need delta B and C. I need small delta BB, BC, CB and CC. Now this delta BC and delta CB, these are same. These are same. What is the reason? This is through the law of reciprocal deflection. Maxwell law of reciprocal deflection. That deflection at B due to load at C and deflection at C due to load at B, these will be same. So to calculate delta B, delta C, small delta BB, this one and this one, I can further move to this one. Delta B, what is the delta? This and this, keeping in view this one. ये मालूम करने के लिए अगर कैपिटल डेल्टा है, मतलब है कि ड्यू टू द अप्लाइड लोडिंग, ठीक है? And if it is due to unit load, then this will be converted into small m. So for delta B, it will be MB into MB. What does it mean? It will be multiplied with this one. So for delta B, multiply these two values. For delta C, you multiply this with this one. Okay? For delta dash BB, क्या मतलब है कि deflection due to redundant force at B, when the redundant force has been applied at point B. ठीक है? So it will be deflection. मैंने पहले भी इसको explain किया इसी तरीके से. So this is so it will be multiplied for delta B. These in दोनों को you will be multiplying these two values. Delta C के लिए these two will be multiplied और small delta ये delta जो dash BB है delta dash BB जो हमने पहले निकाला तो it is due to this is the effect of load at point B when you have applied the unit load at B. So it will be you will this will be replaced by MB. So MB multiplied by MB, it will be M square into dx, M square B into dx. So this will be twicely. इसको डबल कर दें 0 0 0 0 x square. X square जब आए when you will be placing x square over there and the limit is 0 to 3, then you will be getting this one. Similarly, when you will be double this x plus 1 minus 1 into x plus 3, it is if it is square, then you will just open it, take the integral, then you will get this one value. So similar is the case with this one. So you will be finding out this one, these values. Now from this one, after you have calculated, then you will be summing up total. This one, delta C, sum this one, sum this one, and sum this one. This can be obtained by multiplying these two parameters. 0 multiplied by this one, 0. इसको इसके साथ multiply करें 0, and limit will be 0 to 3. And similarly, you multiply this factor with this one, and you apply the limit of 0 to 3, you will get 36. Multiply these two values, 144, and you will be getting these values. And this summation is the final value. Now, in place of, if you see the equations which were developed, you will be calculating this one delta B, ठीक है, और वो ये जो है वो वहां से आप कैलकुलेट कर लें, वहां से जो समेशन है. Similarly, delta BB, this will also be taken from the table. Delta BC from the table, delta CB from the table, CC from the table. Now these two values are same. So this one.
Excuse me, sir. Sir, Mubin Hussain कह रहा है कि admit कर दें.
ठीक है. Now ये मैंने कर दिया उसको. तो
ओके सर.
अच्छा, ये जो है ये डेल्टा डैश जो है ये टोटल नहीं है, इसमें देखिए ये जो है ये बेसिकली VB के साथ मल्टीप्लाई होकर ये डेल्टा BB है, ठीक है, डेल्टा BB. Similar is the case over there. This is small delta, इसको भी चेंज कर ले, small delta, इस तरह का small delta. If you have prepared the table, it should be replaced by this one, delta BB, delta CC. Are you listening, everybody? Anyone from the class may respond. Is it okay? Small delta. This is not like this one. This is this one, like this one.
डैश वाले जो है ये वाले.
हाँ, डैश वाले जो है ना, ये डैश वाला नहीं है, ये है डेल्टा स्मॉल डेल्टा, ये वाला, इस तरह का डेल्टा. This is delta BB. This is delta BB, not delta dash. This is not delta dash. This is delta BB. और ये वाला जो है, this is delta CC, small delta. this is, I have assumed, taken it to be capital. ये जो triangle है, this is capital, and this delta is small deflection. So this will be delta, small delta. Delta BB, this is delta CC. Please correct it. And
Okay,
I
sir.
will be, हाँ जी, मैं इसको ये So when you will be putting the values, now we see the solution. Now this is the solution. You can see this is the compatibility equation as we have derived earlier. Delta B, in place of delta B, I have put the values 12,780. This has been found. You can see 12,780. This is delta B. For delta C, it is 35,100. For delta C, it is 35,100. For delta BB, it is 72. You can see delta BB, small delta BB, it is 72. This is 72. So you will be writing corresponding values. Delta BC 180, ये भी same होगा और ये C भी same होगा under the law of Maxwell reciprocal proportion, yeah, displacement. So you will be getting this equation, third one and fourth one. Now you can see this is VB, ठीक है, ये भी VB है. This is VB, this is VB, this is VC, this is VC. Now you can simultaneously solve and you will see, you can see now, this is VB minus 150 and VC is minus 25. Now from the result you can see that the assumed directions of the forces, those were not right. Those were not right. It should have been applied upward. The assumed direction of downward application of the load, that was not right, and it should have been applied upward. Now, once you apply this one upward, this applied upward, this is known, this is known, this is known, this is known. Now, this is cantilever beam simply. This moment can be found, this force can be found. Sigma fx is simply 0. It's well known. Don't need to go into detail this one. And also, it should also be noted that in the horizontal direction, the beam is so stiff, it will not be moving rightward. So we will not be considering its deflection along the x direction. So keeping in view, 25 plus 115 minus 120 minus 80, it comes out to be upward 60. And as far as moment is concerned, 25 into total, 80 into this distance, 115 into this, and 120 into this. To counter it, net effect, it is 90. And if you draw the shear force and bending moment, this will be like this one. Okay, so this is the ultimate solution. This is the ultimate solution of the numerical. Everybody got it?
Yes, sir.
Okay. Now we move to another approach. This one. Hurry up, draw it. Now in this case, simultaneously, या ये इसको आप देखें, ये आपको मिल जाएगा सब कुछ, कोई मसला नहीं है, हर चीज आपको ये जो है ना, ये मैं आपसे शेयर कर लूंगा. If you can draw it, you can draw. However, now in this case, see, this is total, this is fixed ended beam. Now it is basically, if you see, then over there are three reactions, okay, and we are having three equations of equilibrium. So excess is 3. Now it is known, listen carefully, it is known, it is well established that there is no horizontal force which is acting on this beam, not on the support. It means horizontal force is 0, no deflection along the horizontal direction is there. So I may say that it is known horizontal force is 0. So I am left with 2 degree of indeterminacy. 2 degree of indeterminacy. What is the reason I have reduced this one? Reason is that I will have to apply force in the horizontal direction, which is immaterial. Of no usage of you, and this is useless. Okay, so I need 2 equations. 2 degree of indeterminacy is there. In general, it is 3 degree of indeterminate structure when you talk about degree of indeterminacy. But when you are considering the force method, over here I will have to formulate the equations according to the unknowns. If there are 3 unknowns, 3 equations will be developed. But this is well known to you, this is well established that delta x is 0, so I need not to go into detail by considering the horizontal reaction. And at this moment I will say that only 2 unknown forces are there. Am I right? CR, GR?
यस सर।
Yeah.
सर इसमें ये जो हमारे पास यूडीएल लग रहा है उसकी इंटेंसिटी वो नजर नहीं आ रही कितनी लिखी हुई है।
मैं आपको बता देता हूँ, ये W है, दिस इज W।
ओके सर, ओके सर।
GR,
Yes, sir.
इज इट ओके?
Yes.
वो समझ आ रही है कि नहीं आ रही?
Sir, are you?
अच्छा, चलो शुक्र है अल्लाह करे आ जाए। ओके जी, now in this case I will have to consider 2 forces as redundant, linear and circular, rotational, ठीक है, linear and rotational. Now it can be rendered into primary structure. I can break it into number of beams. It is equal to this beam. I have considered either this one as redundant or this one can be considered to be redundant. Over there, now these are, in this case, 2 forces have been considered on both ends. The circular, ये जो movement है, these have been considered to be redundant. So this is the beam. This beam is equal to this beam, ये दी हुई है, with actual loading, primary structure. Then this is unknown and this is unknown. Remaining structure is simply supported. And you will develop the equation. You need 2 equations. What are those? Theta A due to applied loading and theta dash A due to redundant moment, and theta dash AB due to MB redundant should be equal to 0. This is one equation. Theta A, theta dash A, theta dash AB should be equal to 0. This is one. For B point, theta B, theta dash BB, BA आएगा, and theta dash BB. What is this one? Theta AB, ये क्या चीज है? Theta dash. This is rotation at point A due to moment at B. CR, ठीक है? Rotation at A due to moment at B, rotation at A due to moment at A, rotation at this one, rotation at B due to movement at A, rotation at B due to movement at B. So these two are the equations, and you can solve these two equations simultaneously, and you will be developing the same table, and finally you will be putting the values. And what you have found in the previous numerical, unknowns. Over here, unknowns. What are unknowns? MA and MB. And in the previous, VB and VC. So in the force method, approach is to find out the force. Unknown are forces. Unknown are forces. And you will be, first of all, you will be finding out the redundant forces. Then you can move further. So this is for the case when you have considered two moment cells redundant. Now there comes another case where force and moment, these have been considered simultaneously, force and displacement. What it means, you can see this is a beam loaded with P, moment is this one force. Now apparently you know that there is degree of indeterminacy is 3, no doubt, but as you know, in the horizontal direction, it should be kept in mind everything. In the horizontal direction, the beam is so stiff that it will not be showing you any displacement, any in the horizontal direction. So I consider this HC is equal to 0, displacement B 0 है, deflect सारा कुछ 0 है, इसलिए I will not be considering it. Only I need two equations. So two equations will be developed. I need to solve these two equations. How can I consider VC and M as redundant? VC and MC as redundant. These are the two forces which have been considered to be redundant. Against VC, there will be deflection. Against MC, there will be rotation. Everybody is listening it carefully. Anyone from the class? The other ones?
Yes, sir.
Okay. Acha. Corresponding to VC, there will be deflection. Corresponding to moment, there will be rotation. There will be rotation. Okay. Now, this render it, if I change it into primary structure, then I have removed this one, this rotation and this force, and corresponding to this one, deflection and rotation is there, plus. Now there are two forces, moment and VC. So I will be having two diagrams as well further. The one will be with the application of VC. I can apply downward or upward. ठीक है, यहाँ पे मैंने नीचे से शो किया है. It may be applied downward or it may be applied upward. It will be depending upon your choice. There is no binding. It should be kept in mind. Everybody is listening. I hope. So I have applied it vertically downward. Similarly, this is the moment. I can apply it to be this way, clockwise, or it may be acting in the counterclockwise direction. Now, in both the cases, you can see under the application of load, there will be deflection, there will be rotation as well. You can see if I draw the tangent to this curve, if I draw the tangent to this curve, it will be this rotation. Similarly, under the effect of this redundant, there will be deflection as well as rotation at the tip of this beam. It will, if I draw the redundant, if I draw the tangent to this curve, it will be theta cc dash. Similarly, if I use to apply MC at the tip of the beam, cantilever beam, then under the effect of this MC, there will be deflection and there will also be rotation. So this is the breakage of the actual beam, and under the law of superposition, these three combination gives you the original structure. Combination effect, combined effect of these three portions, combined effect of these three portions, okay, will be equal to the effect of this beam, right? Now, Haji,
सर एक दो स्टूडेंट कह रहे कि एडमिट कर दे।
क्या मसला है? उसको मैंने नहीं करना है, HB को मैंने नहीं करना।
सर वो एक और भी है, मोहसिन भी है।
मोहसिन, चले। अच्छा, तो keeping in view this one, what will be if I consider the deflection? Then deflection delta C plus delta dash CC plus delta double dash CC. I have written it as double dash, and double dash shows the effect of movement. Double dash shows the effect of movement. So ये जो है, so it means the dv delta C plus delta dash CC plus delta double dash CC should be equal to 0. This is one equation. Delta C plus delta dash CC plus delta double dash CC is 0. Why? In the step, this is stable structure. This is stable structure. So according to the rules of mechanics, it should be considered on the same lines as is available to us. Now, as far as the rotation is concerned, theta C plus theta dash CC plus theta double dash CC should be equal to 0. So first equation is this one, and this has, and you can see all the deflections are downward, 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 downward. All are downward equal to 0. Some summation है basically. So चूंकि एक ही direction में, so I can take it as this one. Now this double dash, how can I define? Deflection at point C due to load at C. So VC into delta CC, and double dash CC means the deflection, note it, deflection at C due to moment at C. Deflection double dash की वजह से, I have separately given the notation. Delta double dash means deflection at C due to moment at C, and it will be moment at C, this one, and deflection, चूंकि ये moment से आएगा, it will be multiplied with the flexibility, and what will be the subscript? It is deflection at point C due to unit movement. Alpha corresponds to unit movement. Alpha corresponds to unit movement, which has been applied at C. This is the first equation. For the second equation, theta CC must be equal to 0. Direction is same. This one. All may be negative or all may be taken positive. And what is this one? I can define it. It is theta C due to applied loading in the primary structure. This is VC, and this is the rotation due at point C. This is the rotation at point C, rotation at point C due to force at C, linear force. This is delta, not alpha. This is delta, not alpha. This is delta, not alpha. Note it, please. This is rotation. Due to rotation, it is alpha. Due to rotation, it is alpha. But this is the effect of VC. So this is linear. So I have written over there delta. So it will be rotation due to unit load at point C when load has been applied at point C, and that double dash MC into alpha C. So this way you will be having the table, and this table is available with this one. This is available, और ये जो है ये आपके पास CB और BA ये सारी calculations और ये सारा कुछ दिया हुआ है. So this was the basic approach that was adopted. Now this is regarding the when we are considering the force and linear force and the moment at the same time. Now, if I consider that, as if I assume that any one support is settling, then you will be considering it on the same lines. There is no difference in the previous approach and in this approach. This is the support settlement conditions. Suppose, listen carefully, see at the slide. This is a beam having 3 supports, and its degree of indeterminacy is 1 or 2, 3, 4. Roller, hinge. 4 minus 3, 1. 1 is the degree of indeterminacy. Secondly, I assume this is given that B is settling by 40 millimeter. What will be if it is not given? Suppose 40 millimeter is not given. What will be the condition? Situation will be very simple, that I may be considering the VB as redundant, and at this support all deflections should be 0. All deflections should be 0 if it is not given. क्यों भाई CR ठीक है? GR?
Yes sir.
CR?
Yes sir.
ठीक है ये?
Yes sir.
और GR?
Yes, sir.
So, acha, if it is not given, then some will be 0, and if it is given, then what will be the equation? Equation will be considering the support B with redundant force. I have assumed, इसको मैं redundant बना लेता हूँ, इसको मैं remove कर देता हूँ, तो क्या ये फिर क्या होगा? फिर ये होगा कि you can see it very simple. 100 is the applied loading. I have removed it. सपोर्ट को रिमूव कर दिया, रिडंडेंट समझ लिया, तो मेरे पास 100 किलोन्यूटन अप्लाई लोडिंग, ये दिस इज द प्राइमरी स्ट्रेंथ, एंड अंडर द इफेक्ट ऑफ दिस प्राइमरी लोडिंग I may calculate the reactions. This is 75, this is 25 from the calculations. ठीक है, सिंपल, जैसे आप वो करते हैं. प्लस if I break this structure into primary structure plus redundant force के साथ, I have applied this VB, ठीक है, redundant force. Then under the effect of this 100 kilonewton, there will be deflection, which is known as delta B, Under the effect of this redundant, it will be delta dash B. BB आप कर सकते हैं, BB कर सकते हैं. So it will be delta dash BB. ठीक है, delta dash BB, या अगर आपको समझ आ जाए तो delta dash BB, ठीक है. So now what will be the equation? Equation will be delta B plus delta dash B should be equal to 0. Delta B plus this deflection should have been 0 if settlement is not given, and if support is settling by 40, then it will be equal to 40. This is simple. और कुछ नहीं, और कोई फर्क नहीं. हाँ जी, anyone from the class anyone from the class except G or CR. If you are having any confusion, you may ask any question. Please come forward without any hesitation. If you have not understood, you can. Ji. Yes, you can use any other method which is available under the umbrella of basic mechanics. As I have told you that table is available, ready-made, theta and deflections, rotation and deflections, those are available, and you will have to synchronize with the synchronize the tabular values with your actual structure. ठीक है, उसी तरह का टेबल में भी मौजूद हो, वो जो है फार्मूला और आपकी लोडिंग की कंडीशन सेम हो, तो आप वो डायरेक्ट इस्तेमाल कर सकते हैं जी। मोस्ट वेलकम एवरीबॉडी। इफ यू आर हैविंग एनी कंफ्यूजन प्लीज लेट मी नो।
सर
जी
सर, जो सबसे पहले हमने क्वेश्चन किया उसमें जब हमने फोर्स की वजह से जस्ट डिफ्लेक्शन कंसीडर किया, लेकिन सर जो हमने जो सेकंड नंबर पे किया उसमें जिधर हमने फिक्स पोर्ट को रिमूव करके लगाया, तो उधर सर हमने फोर्स की वजह से डिफ्लेक्शन और रोटेशन दोनों कंसीडर किए हैं। सर इसकी क्या वजह है?
ये दिस इज योर ऑप्शन। सी once again I revise it. This one ऐसे ही है ना, इसमें मैंने क्या किया, दिस इज माई ओन चॉइस, बेटा। अच्छा देखो, अगर मैं ये नहीं करता, देखो ये है कि अगर मैं यहाँ पर ये मैं रिमूव कर देता हूँ, फर्ज करो लीनियर, कोई ऐसी सपोर्ट नहीं है जिसमें मैं इसको तब्दील फिर कर सकूं और जहां पे मोमेंट भी आता हो। क्या मतलब है, ये देखो